see. All right, so we have the laws of indices. This is a summary of all the laws of indices. And so just a reminder about the laws of indices. First of all, with all of these laws here, you could see mostly with all of the laws here, when it comes to addition and multiplication and all of that, mostly the base number must be the same. Mostly the base number must be the same, right? So we're just reminding ourselves that when you are multiplying two base numbers that are the same, you can add their indices. And this is a basic example here. This here, you could see that when we are dividing numbers that are the same base, so it's like an x and an x, well, then we could subtract the indices, right? So numbers that are of the same base. In this one here, you could see that when we have a number that is like, 10 cubed, right, to the power of 7 on the outside, you actually multiply the indices. So when we have a power inside and then you have brackets, raised to a power. So a power raised to another power, right? We multiply the indices. Yeah. Anything to the power of 1 is itself. So you are supposed to know that if you see x, that means x to the power of 1. Even if you see the number 17, that means 17 to the power of 1, right? You can see here that anything to the power of 0 is 1. I don't care what it is. If it's to the power of 0, 1 is what it is. Right? We could see here we have two different numbers, right? But all raised to a power. That means that each number inside of that there is raised to that power. Now this comes from another rule to say that if you have numbers multiplied inside a brackets all raised to a power, that power is, remember, it comes from this rule here, that you multiply the power outside to the power inside. So you're multiplying the power outside to all of the powers inside. Yeah, so this would be x cubed, y cubed, z cubed, right? Another example is, what if we had x, y, z, and the y was squared? Yeah, and you had the cube on the outside. Well, that means that this cube will multiply by everybody. It'll multiply by everybody. So cubed, so it'll be x cubed. It'll be y, 3 times 2 is 6. And z cubed. And so these are important things to take a look at. Important things to kind of know. Yeah. Remember, anything, so that covers this one. So this one is pretty much just like this one, where if you have something in brackets, all raised to a power, that power could, you could put that in on top of everybody, right? The numerator and the denominator. We have this one here, and this one says anything to a negative power really means 1 over the positive power. Remember this. This one does come in handy. And then there is this one here. Anything to the power of a fraction. The denominator is what is give you the root. Yeah. And the number on top is the power. Right? But it has something that this doesn't tell you. And we remember we looked at it. We looked at it in the last class. We looked at it very carefully, very specifically. We looked at it. A to the power of x over y is equal to, so the bottom is the root, right? And you know what, I'll just do it this way. Check this out, right? Just to remind you. Remember, this is a fraction, so this could mean two things. This could mean 1 over y times x, or it could also mean a to the power of x times 1 over y. Yeah. And remember, we spoke about this, right? And so whilst the y will always represent the root, in this case, we have the square root of, well, the y root of the number, all raised to the power of x, right? And in this case, we have the number raised to the power of x, and then outside of that, you have the y root. Okay. So no matter which one it is, both of them are the same thing. And that is kind of cool when you think about it. Right? That is kind of cool. So for example, if you have like say 10, all right, let me see if I have a number. All right. Like let me just say I have 5 squared. All right, now. All right, yeah. Let me see if I have 9 to the power of 3 over 2, right? That means that the 2 is the root, is a square root we're dealing with. So this could mean the square root of 9 all to the power of 3, or it could mean 9 cubed all to a square root. They are both the same thing. That is what this rule is telling you. So this rule here does go real deep with it. This rule does get deep. And so knowing all of these tiny little things, because trust me, some of these algebra questions gonna hit you a little bit hard. Yeah, you're not going to get all of them. That is the point. That is the point. So today we're doing questions, right? So we're gonna start off with some easy questions first. So I have some questions here. Let me just warm up with it. Do the ones that I mark off. Do those 1, 2, 3, 4, 5, 6, 7. 7 questions. Let's see if we can get it done. And so you can see that 10 to the power of 6 minus 4, because we are dividing. So we get 10 to the power of 2. 8 minus 1, which is 2 to the power of 7. Anything to the power of 0 is 1. Anything to the power of 0 is 1, right? So this is really 3 multiplied by 1, which is 3. With this one here, we have 25 to the power of 3 on 2. Remember the denominator, right? This is 25 to the power of 3 on 2. The denominator is what gives us the root. So this is the square root of 25 all cubed, right? So we can also say is this we can also say is 25 cubed all to the square root, but that doesn't really help us, right? This one is a little easier to do because we know the square root of 25 is 5, so the answer here is 5 cubed. We do not have to expand it out, right? 5 5s are 25, well 125 if you actually work it out. Over here, we multiplying 3 times 2, so we get 2 to the power of 6. And over here, we multiplying 4. This is 3 to the power of 4 multiplied by a quarter. So these will cancel. You'll get 3 to the power of 1, which is 3. All right, so that was warm up. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 questions. Don't try not to take too long. I'll just go quickly with this one. This one here is just x to the power of 1, right? Multiply means we add in indices plus 2, so we have x to the power of 3. Over here, I have y to the power of 2 plus b, and I can't do anything with that. I can't add 2 and b together. So this is the answer. Just leave it so, right? Over here, I'll have t to the power of 4 minus 2, which is t to the power of 2. And over here, now I gave you this one for a reason. You minus the indices. So these two things are the things you are minusing. So it should be x to the power of 7 minus 2. Yeah, you're minusing the indices, and so you minus them. So I hope nobody went 7 minus 2, because 7 minus 2 is actually 7 plus 2. And this is why the laws of indices, those other questions there are harder, because, not because of the laws of indices, but because they require you to know everything. Look, this is an example of us having to know directed numbers, yeah, to be able to get this one. Anything to the power of 0 is 1. I don't care what it is. In this case here, we have x plus, I hope you're following, anything to the power of 0 is 1. So this is x plus 1. We can't do anything with that. And with this one here, remember, and I'll do number 27 just for the hell of it. Whenever you have a number outside the brackets, you multiply it to the number inside. So this is x to the power of 3 times 4 3s are x to the 12. And so when we reach numbers like 28 now, you do the same thing. You multiply 4 times 2 to give you a to the power of 8. And then you multiply 4 times 4 to give you b to the power of 16. And this one here is the same thing. Anything outside the brackets, you multiply on the inside. So this is minus 1 multiply by minus 1, which is p to the power of 1. And this is minus 1 multiply by 5, which is q to the power of negative 5. Yeah. So the brackets thing is a multiply. And so we could see here, this is a to the power of a half multiply by 3. But remember, this is 3 over 1, right? So you're multiplying your numerators and your denominators to give you a to the power of 3 on 2. And that's pretty much it. That's all you had to do here. If you want, you could have come the extra mile and you could have say is the square root of a cubed, or you could have say it is a cubed all square root. Yeah, remember, these are all the same thing, which is kind of amazing if you really think about it. So now we're gonna reach the more challenging ones. Rewrite the following expressions using positive indices only. So you see here how this is 1 over x to the power of negative 1, and this is y to the power of negative 3. Well, now I want positive indices only. So find a way to take them negative indices and make it positive indices using your laws of indices, right? You know that it have a law about negative indices, right? What is the one law you know about negative indices? This is the law, right? The law here is a to the power of negative n is really 1 over a to the power of positive n, right? This is the only law you had to know. So imagine this is a to the power minus 1. Yeah? That is 1 all over a to the power of 1, which is 1 over a, right?
Yes, sir.
Right? But what is a? A is 1 over x, right? So this is 1 over x, and yeah, that looking real ugly. Let me simplify it. Well, how do we know to divide by a fraction? And you had to flip this and multiply.
Yeah.
So it will be 1 multiplied by, and I go flip that, x over 1. Oh gosh, where's 1 multiplied by x? And well, this one here is a direct application of the law. This law here, so y to the power minus 3 is 1 over y cubed. So it's a direct application of your laws of indices. So we have these five here, 1, 2, 3, 4, 5. Simplify the following expressions. So simplify these things. Right. So let me see what's going on with this now. Remember when you're multiplying, right? And we're talking about here a to the n multiply by a to the m. That is, you have to add your indices. So you can see here all of them multiplying. So we have to add all of these indices. So this will be 2 to the power of this n plus the 2n plus the other 3n. So we have 2 and 3 is 5 and 1. 2 to the power of 6n. The rule did use 2 numbers, and it's the first time you would have seen it with 3 numbers. So it does work with 3 numbers as well. In fact, it'll work with any amount of numbers. Once all of them have the same base and it's all multiplies, you could just add your indices. That is, that is what the whole thing is about, right? Let me see, we have to add the indices, right? So we add in the indices here. So all of these here, we will be adding them, right? So a to the power of 3 plus 5 plus minus 2, right? So this gives us a to the power of 3 plus 5 minus 2. Because this plus don't really matter there anymore, right? And so that is a to the power of 3 and 5 is 8 minus 2 is 6. And I mean, I will just do this one. This is x to the power of 2 plus 4 plus 3. So x to the power of 4, 5, 6. 6 and 3 is x to the power of 9. Right, so you see, you add the indices here. Now take a look at this one. If you notice, right, this is multiplied by this, which is multiplied by this, which is multiplied by this. So multiplication does glue numbers together. So all of this is glued together. Well, the first thing I'll do is I'll expand the brackets, and by expanding the brackets means I'll multiply the indices. So 4 times 2, that is p to the power of 8, right? And then 4 times 1 is q to the power of 4. Then I have a multiply, and I have this side here. I have this side here, which is 5 times 2, which is q to the power of 10, p to the power, and notice they in the different order. This one have p first, this one have q first. So yeah, so 5 times 1 is p to the 5. Now, because all of this is a multiply, means multiplication is commutative. So this is really, I could group the p's together. Is p to the 8 multiplied by p to the 5. Then you have this big multiply in the middle here. And you have the q to the 4 multiplied by q to the 10. And so we could see we could add these indices. So p and p, 5, 6, 7, 8, 9, 10. No, wait, 8, 9, 10, 11, 12, 13. So that is p to the 13 times, I don't need to put the multiply, q to the 14. So you see I have 8 cubed b to the minus 2. That I have no brackets or nothing, so I can leave that so. A cubed b to the power minus 2. I had this big multiply here. And now I'll expand these brackets here. So 4 times 2 is 8. A to the power of 8. And then 4 times 2 is also 8. B to the power 8. Right? And I could just add the indices for the A. So it's A to the power of 3 plus 8 multiply by B to the power of and you're adding your indices, minus 2 plus 8, right? So this will give me 8, 9, 10, 11, a to the 11, and b to the 8 minus 2 is 6. Simplify these two expressions. So the thing is, right, that the first thing I'll do is expand out all of these brackets. So you know that the 3 could multiply, this m is to the power of 2, right? But remember, the n is to the power of 1. And remember, the 2 is also to the power of 1. So when you're multiplying, you have to multiply 3 by each one of these indices here. So each one of them is a multiply, right? So this will be 3 multiplied by this 1 will give me 2 to the power of 3, right? 3 multiplied by this 2 will give me m to the power of 3 2s are 6. And then 3 multiplied by this 1 will give me n to the power of 3. Right? I'll write them with a little space, but they're all supposed to be together like a multiply, right? So they are one number, even though I write it with a little space there. Yeah. And so now we have to expand these brackets. This m is to the power of 1. So when you multiply 2 times 1, you'll get m squared. Right? And if you multiply 2 times 3, 2 3s are 6, n cubed, no, 2 3s are 6, so n to the power of 6. I had this multiply here, and now I have this 4 to the power of 1. So this 2 multiplied by that 1 will give me 4 squared, and this 2 multiplied by this 2 will give me m to the power of 4. Right? 2 2s are 4. So the numerator is 2 cubed m to the 6, n to the 3, all over. Now, because this entire thing is a multiply, means I could add these m's here, right? So I could add, that is m to the power of 2 plus 4. And then I can, well, I can't add the n with the 4, so it's going to be n to the 6, 4 squared, right? So now, what do I have? I have 2 to the power of 3 m to the 6 n cubed all over. I'm going to put the 4 first. You'll see why. 4 squared m to the power of 4 and 2 is 6, and n to the power of 6. Yeah. Now you could see that this m will cancel with this m straight up. Both of them is to the power of 6. 3 of these will cancel with 3 of these. So I'll have n cubed down here. Yeah. So I hope you understand that one, Adi. Yeah, let me know if anybody getting lost there. So what do I have now? I just have the 2 cubed left on the top, and the underneath I have 4 squared n cubed. Right? So the n can't cancel with anything again, but guess what? This could cancel, because what is 4? What is 4? Right? And you'll have to use, look at this piece of skills here. You'll have to use this piece of skills just now. I have 2 cubed over. What is 4? 4 is 2 squared. Isn't that what 4 is? Right? And so isn't that 4 being squared? Yeah, so that is 4 squared. This is 4 squared n cubed. So now we have 2 cubed all over. Remember, we multiply these indices. So this is 2 to the power of 4n cubed. So 3 of these will cancel with 3 of these, and I'll just have 1 of these left. And so now the final answer gives us 1 over 2 to the power of 1 n cubed. 1 over 2n cubed. Now, well, this 5x to the 5y squared, I'm not going to do nothing with that here. That I have no brackets and thing. I want to tackle these brackets first. So notice the story here. I'm going to put 5x to the 5y squared. Notice the story. Even though I am doing nothing with it, I'm writing it again. Don't be lazy about it. Multiply by 3. And now this is the thing I'm going to change, right? This is x to the power of 1. So 2 times 1 is x squared, right? And 2 times 3 gives me y to the 6th. All over 15x squared y. So you can see the story that I'm telling from one line to the next is that I did not touch anything else except the brackets. The brackets is the only thing that changed there. And now I will multiply this 3 by what's in the brackets. And so I'll get 5x to the 5y squared multiplied by 3x squared y 6. It's just a matter of taking out the brackets. That is all. Right? Divided by 15x squared y. We're reaching back by... So now I could look at this and I could add, well, you know, it's all multiply. It's all multiply. So I know when I'm multiplying, I add my indices, right? So first of all, 5 times 3 is 15, right? I have x to the 5 times x to the 2. So that'll be x to the power of 5 plus 2. And then I have y to the 2 times y to the 6. So that'll be y to the power of 2 plus 6. And all of that will be over 15x squared y. So when I simplify this now, this is 15x to the 7, y to the 6, 7, 8. All over 15x squared y. So I can see here now that this 15 cancel with this 15. So the 15s are gone. 2 of these x's are going to cancel with 2 of these. So I'll have x to the power of 5 up here. 1 of this y is going to cancel with 1 of these, so I'll have y to the power of 7 here. So everything cancel in the denominator, so all I have left is x to the power of 5, y to the power of 7. And that is as simple as you could get that. To rewrite the following expressions using only positive indices. So you had to rewrite the questions using only positive indices. Well, anything to the power of 0 is 1. So this is 1 multiplied by whatever this is. So this don't even matter really, right? So this is a to the power of a half multiplied by 4, right? So the 2 will go into 2, 1, 2 into 4 is 2. So you will get a squared for this first one. You see that we have 2x all to the power of minus 3. So we are on number 39 here. All of this over x cubed. So remember this, anything to a negative power is really 1 over 2x brackets cubed. Right? And all of this is over x cubed. So let me just work on that numerator. Because we know that if we take the cube, we could multiply it by the 1 there and multiply it by the 1 there. So this numerator does end up being 1 over 2 cubed x cubed divided by x cubed. Remember, when you're dividing by a fraction, I could call this x cubed, I could call it x cubed over 1. So when you're dividing by a fraction, you actually flip the fraction. So I'll have 1 over 2 cubed x cubed. Multiply, you flip the fraction. So this is x cubed over 1. Right? When I flip it, it'll become 1 over x cubed. So now when I am multiplying fractions, I multiply my numerators. So 1 times 1 is 1. All over. I multiply my denominators. 2 cubed, I have nothing to multiply with this, so it will remain with 2 cubed. And then x cubed multiply by x cubed. Well, I add my my indices, and you will get x to the power of 3 plus 3. 3 and 3 is 6, because you had to add the indices. All right, so this is in the working column here, this is x to the power of 3 plus 3. So we have 1 all over 2 cubed x to the power of 6. That is the final answer. So first of all, that a squared don't have nothing to deal with it. I have no other a's. So I could just imagine that a squared going to remain there. Yeah, so that a squared gonna remain there. Now, because everything is multiply, right? I could remember my laws for multiplying fractions. Right? I could remember my laws for multiplying fractions, right? So I'll put just remember here. Remember, if I have A over B multiply by C over D, I just multiply my numerators and my denominators. So I will have AC over BD. But check this out. If I had AC over BD, I could split this up into all kind of ways. Because we see here, I could split this back up to give me A over B times C over D. That is one way I could split it back up. I could also split this up to give me AC over 1 multiplied by 1 over BD. Yeah? Right? This, if I multiply this, I will get back this. So this here could split up into all kind of ways, you know. I could split it up into AC over B multiplied by 1 over D. The amount of ways that I could split this up, right? I could say A over BD multiplied by C over 1. If I multiply out all of these using your simple laws of multiplying fractions, multiply out all of these, I will get back this. So I could see here that all of these are multiplied. 2 multiplied by A multiplied by B. So I could split this up. I could say, well, you know what? This is 2 over 2 to the minus 3. I'm splitting up the 2's. Multiply by A squared over 1 multiplied by B to the minus 2 over B4. So I didn't really change anything there. If I multiply this out, I will get back the numerator. If I multiply this out, I will get back the denominator. So the important lesson here is when you have all of them multiplies, you could split it up. Guess what? right? Guess what? Going from here to here didn't require any big set of algebra. Going from here to here, that was SCA arithmetic, splitting up the fractions that you multiplied. Yeah. In SCA, we learned how to multiply fractions. Now we could see that you could split it back up. And so now I could work on the two separately, because I know that when you're dividing numbers, you minus the indices. So this 2 is 2 to the power of 1, the top one, minus the underneath one, which is minus 3. Yeah. When you're dividing indices, you minus, when you divide and you minus the indices, right? This multiplied by a squared, and this gonna be multiplied by, in this case, I'll have b, the top number is minus 2, and I'm going to minus the underneath number, which is 4. Yeah, because when you're dividing numbers, you minus your indices. So what do I have here now? I have 2 to the power of 1 minus minus 3 is 1 plus 3, right? Times a squared times b to the power of negative 2 minus 4. So what I'll have here, 2 to the power of 3 and 1 is 4 times a squared times b to the power of, if the signs are the same, you add them and you keep the sign. But I remember, I don't want any negative powers, right? So I will keep the 2 to the 4 and the a squared, and this is going to be multiplied by, what is this? This is 1 over b to the power of 6. That is what the negative power means. And so, when you're multiplying your numerators and your denominators. So from a final answer, I will get 2 to the power of 4 a squared all over b to the 6. X to the negative 1 plus y to the negative 1 all over x plus y. Right? You notice that this have a big addition sign here. So we can't really be going and canceling y's and canceling x's and thing. Right? Because that does only work when it's multiplication right through. Right? So the canceling thing not really gonna work here. This denominator is a problem. We can't really do anything with that. So let me work on the numerators. What has happened when you have a negative indice? What does that do? Where's the rule?
A negative.
Yeah. The rule. X to the power of negative 1 is equal to what? Where's the rule? Know your rules, bro. Where's the rule? When you have the negative indice, you have to do.
We have to do like that is. So we have to do this like.
Somebody, Tony, help him out. When you have the negative indice, what does that do? So that x to the minus 1, that is 1 all over x to the power of 1. Plus that y to the minus 1 is 1 over y to the power of 1. All of that is over x plus y. You understand that so far, Adi? All right. Now, I can't really cancel out nothing there because of them addition signs. I can't really do nothing with my denominator, but I could do something with my numerator. I could add my numerator, right? So with the numerator, I have 1 over x plus 1 over y. And how do we add fractions? You multiply your denominators. X times y is xy. And then you cross multiply. 1 times y is y. And then 1 times x, you had a plus sign, is x. And well, addition is commutative. So y plus x is the same as x plus y over xy. Right, so the numerator here end up being x plus y over xy, and then that divided by x plus y. Well, look at that. Something looking cancelish there, ain't? Yeah, something looking cancelish. That x plus y, maybe it could cancel with that, right? Yeah. Notice when you are dividing by a fraction, so this x plus y, we could take that as being over 1, and yeah. So I could take my numerator, x plus y over xy, and multiply it and flip the denominator. So this denominator is x plus y over 1. Now it'll be 1 over x plus y. And look at that, right? You can see here that the x plus y's will cancel. And 1 multiplied by 1 is 1. And x plus xy multiplied by 1 is xy. So the answer is 1 over xy. All right, so check this out. I can't really cancel nothing here though. I mean, you know, first of all, them minuses here mean that I can't really go and try to cancel 2 into 4. I can't really go and try to cancel 5 into 10. I can't do that because of the minuses. But what do I realize? I realize that 4 is a number that could be expressed in terms of 2. I realize that 10 is a number that could be expressed in terms of 5. So what is 10? Jabari, what is 10? Would you agree that 10 is 5 times 2, right? Right, so imagine 10 is actually 5 times 2. And all of that is to the power of n. Right? Minus 4, which is, what is 4? 4 is 2 squared to the power of n. Are they starting to see it now?
Yeah, boy, I've seen it in all the way.
You want to carry it to the finish line?
So you're going not to... So you're going to like...
So you see, getting it from here to here, this is the, you know, once you can get from here to here, you can reach the finish line. It's realizing that you had to split up them numbers and express them into terms of that. So check this out, right? N, remember this 5 is to the power of 1 and this 2 is to the power of 1, right? So n times 1, right? That's going to give me 5 to the n times n times 1 is 2 to the power of n minus this n times 2 here is 2 to the power of 2n. All over 5n minus 2n. If I could get 5n minus 2n on the top somehow, well, then I could cancel it, right? I'm realizing that here have a 2n in it, but here I have 2 to the power of 2n. But what is 2 to the power of 2n? Right? This is 2 to the power of 2 multiplied by n. Right? So what I could say here is this is 5n, I'll do it here, 5 to the power of n times 2 to the power of n minus 2 to the power of n times 2 to the power of n. Because nth, when you multiply the same number, you just have to add the indices, right? So n plus n is 2n. Yeah? You following, Adi?
Yeah, I'm following, sir.
All right. So n plus n is 2n. So now, what do I notice? I have two numbers here. And the two numbers have something in common. They have 2 to the power of n in common. Right? Both numbers have 2 to the power of n in common. So I could factorize now. I could pull 2 to the power of n on the outside and say, well, you know what? 2 to the power of n times 5 to the power of n will give me this. Minus 2 to the power of n times 2 to the power of n is what will give me this. All over 5 to the power of n minus 2 to the power of n. This is one denominator. All right, the denominator, you could always see that as one number because this whole thing is one number. So you could see this as being like 2 to the n. And if we see this as x, this is multiplied by x divided by, and we could see this here again as x. So you can see here how the x's could cancel. Well, guess what? This could cancel with this. And the answer is 2 to the power of n.